Hello everyone, my name is Alfred and I'm going to be showing you a demo about how to install Istio Ambient Mesh on a GK cluster. Now naturally you can install this on various platforms, including but not limited to Amazon's EKS, Azure's AKS, K3D, so on and so forth. There are some prerequisites and it varies a bit depending on the platform that you're deploying it on. With EKS, it's pretty straightforward. With GKE, there are a certain few extra steps that need to be taken. So we're going to be covering that as well. So prior to Ambient Mesh being made generally available, it was not compatible with Data Plane V2 on GKE. But as of now, I did test it a while ago. It does work on Data Plane V2. Not just that, it also works with GK Autopilot, though you have to enable certain additional Linux capabilities, netron and netadmin specifically, for the Istio workloads. In this demonstration, we are going to be installing it on a GK standard cluster. I've given each node at least 4 vCPU. I think that's seems to be a decent amount that I think it's a decent amount that the cluster would require. So before we actually begin with the installation, what we're going to do is we are going to add a resource quota. So first let's create the Istio system namespace. Now normally this would be automatically created when you install Ambient Mesh, but because of the extra step that we're doing, what we want to do is we want to install this resource quota. So because the Istio deployment, right, has a system node critical priority class, GK doesn't allow such workloads to be deployed on any namespace that doesn't have a resource quota. So your two options are you can install it in the kube system namespace, which implicitly has a resource quota by default, or you could go ahead and create your own resource quota in the Istio system namespace, which is what I'm doing here. So I'm going to just go ahead and create this resource quota. And there we go. And now when we actually perform the deployment, we shouldn't be getting any issues. In addition to this, another prerequisite I forgot to mention earlier is that you want to have the gateway API CRDs installed. With GK, it comes as an add-on, so you just check a box. With the systems, you may have, it doesn't come installed by default on a lot of systems, so you may have to manually install the CRDs. Alright, so with that said, let's go ahead and install Ambient Mesh. Now, do note that it does require Istio CTL, which I do have installed on this Cloud Shell. Okay, so I'm going to do Istio CTL install, set profile ambient. And this is going to begin installing the various components of the Ambient Mesh. So you'll see the Istio core component, you'll see the Istio D, you'll see the Z-tunnel components and the CNI as well. Those are particularly important. And there we go. Everything has been installed pretty quickly, I would say. So if we check out the Istio system namespace, sorry for the fingers, you can see that we have various components installed. So we have the Istio D, which is the classic. Again, the control plane has not changed. What Ambient Mesh introduces is a new data plane, and this is the biggest component of that. This is the Z-tunnel or the zero trust tunnel. It's deployed as a daemon set. So I have 2 nodes, therefore we have 2 pods. And there we go, everything is good to go. So that's it, that's pretty much it. Your Ambient Mesh has been installed. What we're going to do now is we're going to install the classic sample Istio BookInfo application, and we're going to see what it's like to use it with the Ambient Mesh. So this deployment at the moment, it's being deployed meshless, right? Because I haven't labeled any namespace yet. So we can see that it's deployed in the default namespace, and currently these workloads are not part of the mesh, right? So let's go ahead and install a gateway so that we can actually access the service as well. And if you don't know, so the BookInfo application is essentially, you have the product page microservice which communicates with the other microservices, reviews and ratings and details in the background. And yes, we have various versions of these deployments as well. Alright, so the gateway is created, and you'll notice that along with the gateway we have an HTTP route as well, which directs the traffic to the various backend services. This is the new gateway API which is being used as opposed to the traditional ingress model. So by default, the gateway gets the Istio gateway creates a external load balancer. You could change this to a cluster IP. Since this is just testing purposes, we don't need to make it public at the moment. But let's see what the actual application looks like, right? So yeah, we can see if we go to the load balancer endpoint / product page, we can see that our application is deployed and online. Take a look at the review section, right? So I'm just going to refresh the page a few times, and you'll notice that the UI changes a bit, right? So this is essentially, it's directing traffic to different reviews backend, right? So we have reviews v1, v2, v3, which are showing us different user interfaces. So our application is deployed and online, but currently it's not yet part of the mesh, right? So let's go ahead and include it in our mesh. So let's include it in our mesh by labeling the default namespace with data plane mode ambient. Yeah, this is our namespace where the workloads are deployed, and that's it. So you'll notice that I don't need to restart any of the workloads. They're going to continue running. But now the traffic that they sent, so when for example, the product page was sending to the reviews v1, v2, v3, which is why we were seeing different user interfaces in the browser. Now I don't need to do anything additional, but that traffic is now going to be intercepted by the Z tunnel, right? In a very non-disruptive way. So. Sorry, typo, there we go. So now we see that the communication between these microservices is now being intercepted by Zero Trust tunnel, and it's going to have MTLS enabled. So let's kind of visualize that a bit. So what we're going to do is we are going to install Prometheus and Kiali. Prometheus is going to get some metrics for us, and Kiali is going to give us a dashboard for visualization. My fingers again. Cool. Alright, we're just going to wait for the Kiali pod to start running. And there we go. So now our dashboard should be online as well. Let's take a look. So we've opened it on we've done a bit of port forwarding, and it's port 20001. So let's take a look at it through the browser. And there we go. So we can start to see our application here, but for now the information is kind of limited. So what we're going to do is we're going to actually send some traffic to our workloads, and that way we can actually visualize what's happening. At least we can visualize what the mesh is doing. So I'm just simulating some requests. That's going to go hit the load balancer endpoint. Okay, there we go. So now our load test is done, and we can see that some traffic is hit there. Let's take a look at the dashboard now. So now we can see actually what's happening to the traffic here, right? And if I show the security as well, we can see that you see this lock sign in between on these arrows, right, between the various microservices. So this is essentially showing that this traffic is being encrypted by MTLS. So you can see MTLS enabled. what the mesh also does is, if you see these principles, right? So these are strong identities which have been created by Istio. This is what you would use when you create your authorization policies. We can also see metrics about the inbound and outbound traffic between these various services. So you can see that the mesh is not just giving us security, but it's giving us quite a bit of observability as well. You can see in a very detailed fashion what's happening, and which service is communicating with which service in a very detailed fashion. Right. So now that our application has been deployed, we've enabled the mesh on it as well, and we can visualize it a bit with CLI. The next thing that we're going to do is we're going to enforce authorization policy. So we're going to test out two things. One is the layer 4 authorization policy, which again is being taken care of by the Z-tunnel. And then later on, we're going to try out a layer 7 authorization policy as well. For that, the Z-tunnel is not sufficient. We would need to install the Waypoint proxy handling L7 authorization policies. And that's in the Waypoint proxy is an Envoy-based proxy, as opposed to the Z-tunnel one, which is a Rust-based proxy. So without further ado, I'm going to install this authorization policy, and essentially what this is stating is that it's allowing communications to the product page service, but only from the gateway. So this service account belongs to the Istio gateway, the gateway that we were communicating with. So essentially, if we try to access the product page through the gateway, like we were doing initially, it will allow us to do that. However, if we try to access the product page, say through another service, right, that would essentially not be permitted as part of this authorization policy. So I'm going to go ahead and apply that policy. It's going to start, the Z-tunnel is going to start enforcing it. And let's test out whether or not it works, right? So essentially, if I refresh this, I'm still able to connect. You can still see the UI changing a bit. So I'm still able to connect to the product page service via the gateway. However, I'm going to communicate with the product page endpoint through the curl pod. And essentially, if the policy is working, if the authorization policy that we've enforced is working, we should get an error that says exit code 56. Yeah, there we go. So essentially, the authorization policy is being enforced. So because this curl pod, or the curl pod, which is part of this deployment, does not have sufficient permissions, right? If we looked at our authorization policy, it only allowed the gateway or the service account which the gateway was using. Therefore, this workload has not been permitted. Therefore, it was denied permission to actually connect with the product page workload. And now, let's say that we want to enforce a layer 7 policy, right? This cannot be done with just the Z-tunnel. In this case, we are going to need to use the Waypoint proxy. So we're going to run istio waypoint apply in role namespace. So this is going to apply it in the default namespace. So now we can see that the default namespace has been labeled a waypoint, and now we can see that the waypoint should be, there we go. So we have the waypoint installed as well, and it's ready to go. So now that the waypoint is ready, let's go ahead and create an L7 policy. And what this policy essentially says is that it's going to allow the curl service. So if you remember the service account which the curl pod's using, it's going to allow the curl service to communicate with the product page service, but only using the get HTTP method, right? So if it tries anything else, like a put operation or a delete operation on that service, it's not going to work. Another important thing to note is that if you look at the spec, right, in our L4 authorization policy, we were using selectors, which is fine. And even with the standard Istio sidecar model, you can use selectors even for your L7 policies. However, for Ambient Mesh, you need to use target references. So we are directly referencing the product page service here. We could also reference a namespace or multiple namespaces, but you need to use target refs. You cannot use selectors for your L7 authorization policies. The Waypoint won't recognize it. So we're going to apply this and enforce this policy. Okay, so the policy has been configured. So now we're going to test it out, okay? And what we're doing is we are connecting from the curl pod, and we are using the delete method, and as expected, it's been denied, right? We've only allowed the get method anyway. So let's test out another thing. Let's test out connecting from the reviews workload, sorry. We're connecting from the reviews deployment to the product page. Now, remember, we've only authorized the curl workloads, or the workloads using the curl service account to connect to the product page using the get method. So this should also fail. And there we go, we have an RBAC access denied as expected. Now, let's test what we've actually allowed, right? So we've allowed the curl pod to talk to the product page using the get method. So what we're going to do is essentially see if this works. So if this works, that means that yes, the policy is being enforced, and there we go, we have our response. So we can see that our L7 authorization policy has been enforced, and it's been enforced by the Waypoint proxy that we used. So we used the L4, for the L4 authorization policy, we used the zero trust tunnel, and for the L7 authorization policy, we have used the Waypoint proxy. And that's it. So that's the demo. So what we've tested out so far is we deployed an application, we embedded it into the Ambient Mesh, we showed what the traffic looks like between these services and that it is being encrypted by MTLS. We also tested out various authorization policies, both L4 and L7, and that's it. So it's very simple to set up the Ambient Mesh, very easy to get used to it. You'll notice that these pods that I've deployed don't have any sidecars, so there's a lot less resource overhead, and it's just a more efficient way of running your service mesh. Thank you all. I hope you enjoyed this demo. I hope you learned something from it. I'll connect with you for the next one.